We are live. All right.
Projector.
Oh, the projector. Can we hit the go button? No. So, good evening, everybody, and welcome to TWed for the fall 2019 season. Yay! Woo! Yay! Yeah! All right. And just for those for whom this is new, TWeds are Tetherless World educational sessions. Curiously, totally by coincidence, our logo is almost the same as TED Talks. So TWed Talks will occur this term approximately every couple weeks, and there is a sign-up sheet which has been circulated on the Tetherless World list. These will be interspersed with approximately monthly R-Pirates, the RPI users group meetings, and occasionally, a little bit less than in the previous term, idea talks, which are similar to TWed Talks, but are focused on idea graduates, data analytics graduates. But this term, there's going to be a lot of TWed Talks by idea staff, led off by Minor Gordon, our new Tetherless World Director of
Semantic Web Applications.
As opposed to semantic web, as opposed to data, as opposed to web science, as opposed to
data. Yeah, we're very creative with our director titles.
That's right. Let's go get them.
Right.
All right. So, we're very pleased to give Minor this opportunity to lead it off. A couple logistical things. We are actually not streaming live right now, but we are recording, and it's going to be a screen share video recording, and these will be posted to the Tetherless World YouTube site, richly metadataized, so people can find it the way they've been finding our other stuff. I suppose you've got a set of slides, but you're also free to take questions and this sort of thing.
I'll take questions as we go along.
Yeah, and the only stipulation is Elvis has got to leave the room at 7. So.
Okay.
All right. So
unmute now? Or?
Yeah, go ahead. Unmute. Switch.
All right. So this is going to be a talk about. Great. So this is going to be a talk about testing automation and unit testing techniques, unit testing, integration testing, end-to-end testing. A little bit about continuous integration. These techniques can be used essentially in any kind of projects, from one-person projects to huge projects. Most of this is coming from my experience in industry. I've just been here for 2.5 months now. Before that, I was in industry for 10 years. So I was having to do this day in and day out, writing tests, setting up build pipelines and things like that. So I wanted to try to diffuse some of this knowledge and hopefully help the practice in the lab. So just starting out with the agenda, why do we need test automation? People write tests, they can just run tests on their machine. Why do we need to automate this? So what are we really talking about with tests? We're going to talk about the test pyramids, different kinds of tests, how they're related to each other. How? What tools do we use to develop these tests? What methodologies do we use to develop tests? Finally, when and where. So where are we running the tests? When are we running the tests? The focus here will be on testing for correctness, that the software is correct, and not on performance. So we won't be doing things like load testing, scalability concerns. The general prerequisite is that you've done some coding of some kind and some testing of some kind. It doesn't matter what language. Pretty much everything is going to be language agnostic. It's an overview. It's not going to delve into a lot of specific examples. So getting into the why. Why do we do tests? And why do we automate tests? I think we can all agree that better testing leads to better software. That's been known for a long time. The more tests we have and the better written they are, the higher quality our software. So, but unfortunately, the tests increase in complexity in proportion to the complexity of the software. We have such thing as test coverage. We want 90% test coverage. Well, if you have 100,000 lines of code, that's a lot of tests. At some point, manual testing becomes impractical in terms of time and effort. We need to automate the testing somehow. We can't really automate the writing of the tests very well. You can do that in security contexts and things like that. So we're mostly focusing on automating the execution of the test once we put. So what are we talking about when we talk about automated tests? This is a version of a fairly famous diagram. Martin Fowler, the CTO of ThoughtWorks, espouses this quite often. This is the test pyramid. And the idea here is this is what you should have. You should have a large base of automated unit tests. There should be, so a unit, we'll talk about that in the next section, but it's essentially every small bit of your code. So something like a method. All of your code should be covered by those things. That's not enough. So some people think that's enough. Oh, I just do unit testing everywhere and that's fine. It doesn't really test the interactions between things very well. They're designed to be isolated. So we need another layer of things. Sort of higher level components idea, some notion depending on what language you're in. Then integration between components. So components could also be things like your database interface. And then API tests. We'll talk about those two. And then finally end-to-end tests. If you notice it's structured as a pyramid, and this guy at the end, the eye of providence, is eyeing things. Right? I mean, that's ultimately the very basic thing of, well, does that look right? Does that result look right? The idea is that we have many things here and very few things there. So we write a lot of unit tests. We run them all the time. They're very quick, have very fine-grained coverage. We do very little eyeballing of things. This is what happens in most small projects. This is the ANTIP pattern, the test ice cream cone. You can't see that there, but where we have a lot of manual eyeballing, regression testing. So I made this change. I'm going to poke around on the user interface a little bit and see if anything works. That's a pretty common approach, especially for small projects. And then we have some sort of smaller amounts of automated testing for them.
They're minimal.
Yeah. So it's a little bit odd because typically like unit tests are probably up here, but a lot of people, given the choice of, well, I haven't written any tests. I started out by writing no tests at all. So that's manual regression testing. Where do I start writing tests? I know I need tests. My software is too complicated now to get away with not having tests. Where do I start? Oftentimes they'll say, well, I'm going to do end-to-end tests as sort of bang for the buck. And there's some merit to that, but you end up with this situation. There will always be manual regression testing. There's no getting away from eyeballing things, especially as you're initially developing them. You just need to, like we were talking about in the group meeting earlier, there's some sort of mental model. You don't ever entirely get away from that, but it should be a very minimal part of, it should not be part of the main development workflow in the sense of merging to the master branch and so on.
You're suggesting that this is an inverted priority system.
Yes, this is the ANTIP pattern. Way too much manual testing so that it becomes impractical. So I'd like to just cover these individual types of tests in a little bit of detail. What is a unit test? This is really the workhorse test that almost everyone knows how to write and has written it one time or another. You'll see there's some JUnits. This is sort of a canonical testing framework. It came out of tree programming, Kent Beck, and so on. You're testing individual units of code in isolation. So a unit is different from language to language. In Java, this would be something like a method. In Python, also usually a public method. So you sometimes distinguish between public and private and doing unit tests. But I think people pretty much understand this. So you have an adder of some kind that's adding numbers, and the add is a public method in Java. It's public because we're sort of assuming that the test has access to it in some way. And then you're going to do assertion on the result. So in a large code base, you'll end up with generally one of these per method. I think most people are familiar with these. Integration tests. A lot of people don't do these, and they'll either do unit tests and then end-to-end tests or just unit tests. Integration tests is this idea that you have a little bit larger unit of code. So say your view rendering engine, and you're going to integrate it with the database. You can do this in a couple of different ways. You can essentially have internal integration tests, internal end-to-end tests, more or less, where we integrate everything at once and then test it with some internal machinery. or you can do pairwise integrations, which is generally the preferred approach. The idea with testing is that we need to be able to isolate the source of a bug very quickly with failure. So a lot of testing methodologies, the whole reason the unit test exists is if this test fails, then I know exactly where to start looking for the problem. It may not be in that method, it may be in some methods where that falls, but it gives me a starting place for my debugging. Whereas the more coarse-grained you get, the harder it is to pinpoint a good starting place. Questions? Okay. So if you step up another level, thinking about web applications in particular, where they have a separation between the front end and the back end has some sort of API. Many systems can be described this way, right? The client-server systems. We'd like to be able to test the API without using the actual client. So in particular, if you have an HTTP API or a binary protocol like gRPC or a command line interface or something like that, we'd like to be able to essentially simulate that we are a consumer of the. That's what an API test is. What you end up testing here is the interface's contract. So that's not a word that's used common currency these days very much, but it's this idea that an interface is defined by this contract, which has invariance on inputs and outputs. So like what it sounds like, I'm going to give you this, and you guarantee you're going to give me that. Identify edge cases, things like that. That's ultimately what these APIs or tests are. Yes.
So batch integration tests, you might have a lot of individual modules that you're doing unit tests on, and you use something like JUnit for that. You then write a unit test that combines these modules, and that's an integration test.
I'm going to cover that in the tools slide. Now, this is just an overview of kind of what these things are doing rather than the tools. The short answer to your question is you don't combine the models, so the sum of unit tests is not an integration test. They're testing two different things. The unit test is the goal is isolation, and the integration test is controlled integration. So when a unit test, for example, you don't want the database to be involved as a general rule, because then you're increasing the area of potential failure sources. Right? So not only am I testing my code, I'm testing the database as well, which means if there's an issue, I have to then question if the database works. So the idea is you have this notion of isolation where we want to decrease the sort of radius of possible faults. There's some things you can't assume, like the hardware and stuff like that. Got to make some assumption of what you're integrating, right? That's like the JVM or Java or whatever. But of the things you control, you want to limit them carefully.
Right, well, like say you have example data that you know, and then you test the interaction of the data.
Yeah, that's potentially a unit test, not an integration test. Yeah. Integration is more module to module and module with external things. So like with the database or network service, and so on. The same notion of integration is we have your application is running in a very large environment, and you need to the module may be someone else's thing. Okay? So that's where this typically comes into play. So end-to-end tests, finally, at the very top of this pyramid, test the entire application from the perspective of an end user. And web applications is going to be the browser, we were talking about earlier. We want to actually simulate a user as they're actually going to be clicking through your application. Or there's Unix utilities that expect to do this with command line options, for example. Simulate typing on the command line. So we want to get as close as we can to actually doing what the user is doing, because there's assumptions embedded in unit tests and so on about how certain things are going to be inputs that we can kind of do away with that here. Right? We're actually using the input method of the user. Question?
Testing on browsers.
I'll talk about that briefly. So how do we do this? unit testing tools. There are a lot of them. Most of them derived from Kent Beck's work on X units. So that was the Extreme Programming book. I'm sure it predates him. This was a notion that we're going to define a sort of standard set of things that unit testing frameworks do. I would say that's grown a little bit. I don't recall X unit had a really strong, Extreme Programming had a really strong mocking facility. But the idea is that we are able to define tests in some way and collect the tests into some sort of suites of related functionality. So, for example, a test could be the level of the methods, and the suite would be all of the methods of a class. And then have some support for various common testing patterns like fixtures and executing code before and after and so on. A test runner to actually run these things, and ability to make assertions. So that last bit is really important. Languages come built in with assertions, but they're generally Boolean assertions. And JUnit provides rich assertions. There's a Handcrest library, which is really worth using. Scala test has a similar thing. Chai and JavaScript has should-based expect-based assertions. The idea is then that you narrow down further by having fine-grained assertions. You can really narrow down what the cause of the failure is. So it's worth investing in those things. Note that this doesn't really talk about the granularity of tests, right? So these same tools can be used and are used for a lot of different kinds of testing. You can do all the way up to end-to-end testing with unit tests. There are some more specialized tools that are designed for end-to-end testing. In principle, you can do it that way. Of those, by the way, the Mocha and Chai, the JavaScript tests, I mean, JavaScript in the browser is really hard to unit test because I think it's kind of interdependent there. So a lot of times we will rely on end-to-end testing for browser things, not focus as much on, because there's so much display logic, or it's not business logic talking about there. So unit testing tends to be, the pyramid doesn't really capture that, but certain areas of the code are more amenable to certain kinds of testing. So one thing that you do pretty frequently when you're writing tests, particularly unit tests, but also integration tests, is mocking. This is basically a pretty simple idea. Is you're going to replace part of the application, part that you're not testing, with a fake. So it's going to be a little bit of code that pretends to be a database or pretends to be a network service or whatever. The idea is the same as mentioned earlier. We want to reduce the amount of code that we're testing so that we can isolate players much. That's the whole point of mocking. I don't want to be testing a remote network server in my test because I don't care if he fails at the level of the unit test. So I mock that by saying, I give you the network server an HTTP request, and you hand me back an HTTP response. And that way, I mean, so that I know that it's probably not going to. Yes. Yes. With the possible exception of if you have sort of triangular dependencies between things, like one piece of code depends on both the network server and the database. You may want to do pairwise integration, and so I'm only going to test my application code and the database, so then I mock the network. It's about controlling the scope of tests. So it increases test isolation, also the speed of test execution. Reaching over the network is slow. So having this mock that is just a bunch of memory manipulations of request and response structures. These are also language-specific tools. So unit tests apparently now comes with a mock framework as well, and the famous one in Java is called mock2.
Actually, within the semantic web, we have a special advantage because a lot of the different libraries for semantic web access include in-memory versions of RDF graphs that are functionally equivalent to accessing the Sparkle database.
Yep. It's hard to find in the SQL world. You can get things like SQLite that are in-memory databases, but even then, that's a huge code base because of the complexity of SQL. So big advantage to have in-memory implementations of things. So integration testing, as I mentioned earlier, you typically will use the same set of tools like JUnit to do integration testing, mocking and so on. Because they're test frameworks, they're not really, a unit is about the scope of the test. It's not about, there's nothing really special about the nature of that, right? So typically you would use that for integration testing as well, just with more mocking. And of course the tests are more coarse-grained, so you're testing out a whole package in Java or a whole subset of functionality rather than individual methods. API testing. This has come a long way as people are arguably more API oriented than they used to be, particularly with all the web applications and single page web applications. So they're now specialized software as a services and tools to do this. Probably the biggest of them is called Postman. But there's various clones, and I were talking about one the other day. But you can also use unit testing tools to do this. So I can basically, in Python unit test or JUnit or whatever, I can instantiate an HTTP client and use multiple threads or whatever to call my server. That's a little bit wonky, but it can be done. There's tools for Flask. A lot of web frameworks now supports some sort of tools for doing this without actually managing multiple threads. The nice thing about something like Postman is it's doing things like integrating with Swagger or OpenAPI and really like making sure your definitions are covered and making fit with your schema and things like that. So by using a specialized tool, you're getting something that you wouldn't necessarily get in a generic testing framework.
So does the unit test that actually posts stuff in API,
yes. Okay. It's just really the level of things that we're testing as and scope of the test, yeah. Finally, end-to-end testing. So until relatively recently, everyone used Selenium, and Selenium have suffered from a lot of the failures of the underlying platform, with namely asynchrony. Working with single-page web applications and tests, which are meant to be more or less deterministic, is really hard because of timing issues. And people kind of grew to hate Selenium. So there's still lots of wrappers, and you'll still see that as sort of the de facto way to test websites. Grab DOM elements, wait for this to load, input this text as this thing. You're manipulating a browser. There's essentially a library, the Selenium library, which is communicating over a binary protocol with a web browser to automate it. The basic notion of this. There's been a few new ones recently. One that I particularly like is called Cypress, which is, they redid a lot of the assumptions. So for example, when I try to get a DOM element, it's sort of classic point in time, it's either there or not there. I actually do some automatic retries and things like that, which takes some of the pain away from, takes some of the non-determinism out of the equation. It's also got a lot of nice tool supports, so you can see snapshots of the thing as you're going through. Like at every point, every assertion you make, you can see a snapshot of what the screen looked like, snapshots of DOM, and things like that, which is extremely useful.
So are these, like Cypress, is it sort of acting as a client? And so it's like, is it carrying in its, in its head, so to speak, a model of what the construction would be within the browser, but also being able to serve?
Yes. Yeah, it's automating browser. So you get into some sort of situations where you have non-determinism introduced by user choice, right? Like you need to store state of what I chose in some previous screen or whatever, but part of the point of tests is that you test every workflow, so you kind of like rich determinism out of that.
Right.
Yeah, another nice thing about this is that it's really, you can see here, like it's showing all the requests going back and forth as the URL is changing. It's all these events that are essentially telling you at a very high level what is happening in the browser, which can be extremely useful for debugging queries.
So does it import, for example, like Chrome? So you can say, like, I want this version
It works with any browser.
So it's working in tandem with the existing, so it's not like bolting on the browser's API. It's not doing that.
All the browsers support a protocol which allows you to automate them. They all agree. It was based on Selenium. They essentially forced all of the Mozilla and Chrome and Internet Explorer and so on to support an automation protocol, which is just a commands response protocol in binary. The browser support.
Okay.
Any more questions?
Also, kind of following up on, like often we see bugs where a piece of code works on Google Chrome, but it doesn't work.
Yeah.
You use something like
Definitely.
this will tell you that.
Yes. So typically what you do then is you can have multiple configurations for this. So this thing can read its configuration. You introduce a little non-determinism, but you can basically say, yeah, I'm using this version of Chrome, and I'll alter my behavior based on that. The main form of non-determinism you're trying to avoid is picking random things in the application and taking different paths. Like you want that to be really tightly controlled. But in terms of like non-determinism that comes from browser variations and things like that, you can predict that.
You should just specify your app doesn't work for Explorer.
Or that, yeah.
You can move on.
So yeah, it's pretty nice. End-to-end testing used to be extremely painful because of the asynchrony, and now it's gotten a lot easier in recent years. There's just so many people who do front-end, like complete front-end web applications with so much JavaScript on them that the API testing wasn't really doing it. So, but the front-end testing, unit testing, the tools are not great. They needed end-to-end testing, and it's so painful that they finally like addressed this.
Is something that like something.
It is, but you can. So historically, the way a lot of people did browser load testing, so like user visible performance, which is what most people are concerned about, right? Is they did things like write scripts for Selenium to automate browsers, and there were software as a service companies that said, we're going to spawn 500 browsers in the cloud, and we're all going to run these variants scripts, basically, to automate the browsers. And yeah, that's I mean, if you're a big company with a heavy-duty web application, it's worth investing in. I haven't seen people do that in Cypress, although I've heard it can't do that.
Does a tool like Cypress have, so one of the things you want to test is whether the web app validates inputs and detects invalid inputs. So
Yeah.
it must be like kits of, with this input, throw this at it.
Like fuzzers,
Yeah.
or there are separate tools that just do security type things. Yes, this is really for pretty controlled things.
Well, except, so security, yes, I wasn't so much thinking security, I just meant to verify that for these input widgets, you're doing validation.
Yeah. Well, I mean, presumably, if you put in invalid inputs, at some point you're going to give feedback to the user.
Right.
And that's when you would detect it here. So I grab a hold of the DOM, the input text box or whatever, and I type something, and then I hit this button. So there's the language of this really looks like click and then look for something. So then you would detect it, show the message, very much from a user perspective.
And then does it like suck in a form in order to do this?
In order to, no, you have to do it by hand. Yeah. So what you end up doing is like creating parallels between sort of internal structure, like model view controller or whatever, and then have some notion of a page.
So are there any pre-canned test things like we at RPI and I think the world needs to make all of our HTML accessible?
I wish. There, not in this. There are HTML accessibility checks, like tools that automatically do that.
Tools, okay.
Yeah.
So not just checklists.
or human testing?
Oh, yeah, no, the W3C, some of those tools, yeah.
Okay, they actually, like, John Fisher's people.
Well, they will be pointing us if they
Yeah,
haven't already.
But I mean, we've experienced it, and it's, the lightweight is simply, it's really simple things that they consider, ADA compliant, such as alt tags.
Yeah, I'm looking at the
alt tags
RTI
and font,
list.
I don't know how they do font colors and stuff, but it's like your fonts are sufficiently contrasting and sorts of things. That's one level of accessibility. Actually, I don't know the legal part.
Well, we're all gonna be pounded on.
Well, I know, but I'm talking about the things that I've actually experienced and yelling about. Those are, they're relatively well improved, but they're using those frameworks.
Yeah.
And you can do it yourself.
Run the checker, yeah.
Yeah.
Thanks.
So, a little bit of test-driven development. I have to touch on this. I wouldn't try to evangelize about test-driven development, like why you should do this, but this is extremely common in the industry. You pretty much do this as a matter of course. The basic idea is that you write tests before code, and then there's various mechanics around this. These are the 3 laws. This comes from this page. Clean Coder is Bob Martin. He wrote a book called Clean Codes. Kind of the guru around some of these software engineering practices these days. It used to be Steve McConnell, but okay. So you must write a failing test before you write any production code. So the idea is that the tests in part should be the embodiment of the requirements. This method, go back to the contract thing, this method given this input should do this. I make the assertions that input and output, basically, before I ever write the code. You must not write more of a test than sufficient to fail or fail to compile. So compilation failure counts as a test failure. This is the idea that we hop from one small stable state to the next, right? So we don't want to write a ton of tests and then write a ton of code. You write one test and a little bit of code, one test and a little bit of code. So we constantly move from one stable state to the next. And that's this last point. You must not write more production code than is sufficient to make the currently going test. So if your production code is supposed to do more, you need to add more tests. So the test should kind of go in lockstep. You usually talk about this, you'll hear industry people talk about red, green, or factor. Red is, a lot of this comes from test runners and things like that. Red is, I've got a failing test, I fixed the test by coding something or fixing a bug, and then I break it again, over and over again. So breaking it is adding more functionality, for example, or it's fixing a bug or whatever. The refactoring is the change. Uh-huh. Yes. It depends on how you define item, but unit test is a method, is a public method, generally in Java or Python. Every time you add a new public method, you have a unit test test.
I think when you join a project, it's more nice being here. Do you spend the month or so to get caught up to that, or do you just try to start with good practices from where you're at?
It turns out.
Yeah.
So,
Not that he did that recently.
yeah, I know, right? So the general rule I've seen is that you write tests for all new code, and then you write tests for any code that you touch. So if I'm going back and I'm fixing a bug, then I write a test to prove that the bug exists, then I fix the bug, and the test next. So over time, sort of tests will accrete for old code.
Okay, that sounds reasonable.
If you're refactoring, use your refactor code in order to maybe extend its capability. You do the same thing where you have, and actually I'm doing this with Wise right now. So if there's a piece of code that I'm looking at, I'm like, I don't really know if this is working quite right. I need to make sure that it's going to keep working this way. Write a test that confirms that it's going to keep working that way. Then you can refactor it so that confident that you haven't changed any of the semantics of the code. You have this internal machinery.
The tests are giving you a security around the basic sort of business logic. So I wanted to talk about one of my favorite things, even though it's a little bit less common, behavior-driven development. So this is the idea that it's a combination of test-driven development, which you just talked about, and domain-driven design. And domain-driven design is kind of a hash in terms of the way it's often expressed, but it's basically the idea that we should talk with domain users in domain language. We should have a common language with domain users. And this just extends the idea to say, well, we're going to write tests in the language the domain users understand. So this obviously only applies to fairly high-level things like end-to-end tests. You know, the domain users don't care about our methods as a general rule, although you can kind of shoehorn it that way. But typically, this is talking about whole systems. So we start with the user story. Cover that. That is the idea that the user is giving you something that they want your application to do. As a certain type of user, I want this feature from your code so that I can get this. And attached to that, I have some way of saying, did I actually give this to them or not? So this comes into like definition of done, and so this is then stepping down. I'm actually going to implement this feature, say it's a new shopping cart or whatever. How do I know that it's good from the user perspective? So I define these acceptance criteria, which are ultimately going to be determined by the user. Well, I want to be able to click on this and do this and so on. There's some dialogue there, of course, but given that I'm on this page, when I click on this, then this should happen. So when I click on the carts, given that I'm already added items to my carts, when I click on the carts, then I expect to see those items. Something like that. So there's a really good blog post from TWed Labs about how to write these user stories, how to talk with users about them, and an overview of that. I just wanted to show this more in action. So this is what this looks like in practice. When you talk to the user, they want to, this is an employee banking example. There's an account holder, they want to withdraw cash. So you've got this scenario, which is ultimately defining a little bit of workflow in your application, right? Usually, you know, not the whole thing, but a couple of screens. So I'm going to withdraw cash. Here's the scenario. So I've got some sort of setup, which is an English language description of things. And then the given when then. The really interesting thing about this is we've defined the test in terms of the domain language, accounts and cache and things like that. But we're actually going to use sort of Ghetto natural language processing to parse that and translate that into actions on your application. So usually just regular expressions of some kinds. Given this, I parse all of that, and then I translate that to, for example, commands on Cypress. You go to a certain page, enter some data, blah, 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 set up the whole thing. And then when I do some action, same thing, I translate that to commands on the browser, I, the developer. And then I expect to see that when I have the set of assertions. The great thing about this is, you know, then you can really, this provides a basis of negotiation with clients on user interfaces. Yes.
When you say you do natural language parsing, you write
just regular. So, Ghetto natural language parsing. I mean, you can do it more. There's more complex forms of that, but you want it's semi-structured English. So like, you know, I basically say I'm only going to parse when clauses, and then I'm going to look for account holder, and then this verb, and I'm going to have that be a match group or something like that. And,
but you're not like writing code. You mentioned Regression.
Yeah.
Or are you like as a human looking at this and knowing what piece of code translate it to, or are you actually writing?
So the client writes the client in combination with usually like a business analyst writes these. And then the developer is the one who writes the regex to translate them to actual like browser automation. Oh, yeah, no, that'd be amazing if you could do that.
Well, that's what so if the developer is writing the regex, oh, they do that to kind of make it easier for them.
Yeah, so just parse this. So I can change this amount, right, and I can just reuse that code that there's a set of commands for the browser to do that particular thing on that particular page. Finally, when and where. Most developers, when they're starting out, run tests in their development environments. The price of this is quite convenient, of course. The IDEs all support this, unit testing on the command line. And it's generally sufficient for red, green, and refactor. So I broken the code, then I can fix it on my local system. I don't need to worry about showing it to other people. Given that we're making these really small changes, we don't want to do commits and stuff like that. So cons of this is you're not going to run all the tests this way as you get a really large system. The tests will just get slower and slower. There's more of them to run. There's integration tests, which are testing like databases and things like that, which are just slowing you down. So that makes it less likely that all the tests will be run, which is a really bad thing. We want all tests to run pretty much whenever we make significant changes to the system. It's also less isolated. Your system is set up for development. It's not a production system. Production system is typically, for example, only has the JRE, not the JVM, things like that. So we really want to emulate the production system. It's only one environment, so you've got one particular version of your OS and so on. And it also may not reflect the latest code from others. So the idea is that we want the tests to run somewhere else, and we want them to run a lot and as fast as possible. So that's where the continuous integration comes in. Once we've made some significant changes, we're going to push the changes somewhere else, and some server is going to pick them up, recreate a production-like environment, and run all the tests and tell you what failed. There's a whole bunch of different tools for these. We use those top two. Jenkins is one you self-host, and then the others are software as a service. We use Circle CI and YS. A lot of these now are using Docker because of the isolation things. So I can spin up multiple operating systems really cheaply using Docker. You can test many variations of deployments. So in summary, automated testing will help you deliver better software faster. I hope I convinced you of that. There are many different kinds of software testing, and you basically need them all in proportion to the pyramid. And even for small projects, it's worth learning some of these custom-built tools, particularly the end-to-end testing tools if you're building user interfaces, as well as doing continuous integration. So even very personal projects that I do have continuous integration, so it's well worth the effort to set up. Questions? Yes.
You have a rule of thumb for unit test granularity. So is it one for method generally, or
For public method.
exception for that? What kind of
There generally should not be exceptions, because if you have public methods, it's one per public method. So,
public method?
yeah.
Also, no private.
You could ask multiple people and they would give you different answers, but typically, like, public is.
You're not going to you can't test the private method if you're being honest with yourself.
Yeah, it's really hard to test. You don't want to do indirect testing with unit testing. So I don't want to be sort of testing a private method by going through a public method. That's not going to work. So the testing in Java, for example, is typically package private or public. The test is in the same package, so you don't have access to the private method directly anyway. So one public method.
The private methods are, in a sense, if you think of the class as a contract, then the private method is
Exactly.
The public method actually does what it's expected to do. It doesn't matter how the private
method works. Yeah.
Another question would be, if you have MVC updation, does that mean that for the majority of the time you have to multiple?
Yes. And you get into things like passive use, where you can basically replace both the model and the controller. Yeah, there's special patterns for testing MVC that don't necessarily apply to generic algorithmic code. I thought that was a little bit beyond scope, like testing patterns. That's the whole universe of.
You mentioned definition of done. About that.
Well, yeah.
Yeah.
Yeah, so it's a common problem in software development that the developers just don't know when to stop for whatever reason, and so you have to basically agree what that's going to be. That's the definition of done. You can do that on multiple levels. You can say, well, acceptance criteria, I fulfilled the acceptance criteria, but I haven't documented my code, so there's some sort of like, it's supposed to be holistic in some ways. I don't just want functionality, I want all my other tests to continue to pass and documentation and code review and things like that. So, but in the end, a lot of it is hinging on what you do.
Here's a weird question. Okay, a million years ago, I was a test equipment development engineer. And I started down that line, that career path, before the creation of built-in self-test hardware. And now, so my question is there some sort of equivalent notion in software?
Yeah, sure. Of self-testing or external testing?
Self-testing, actually. Well, self-testing and possibly components testing other components automatically.
Yeah, that was this whole sort of IBM autonomous computing thing way back in the day. Is like 50 years ago, of self-healing systems. So the systems would watch each other and correct their own errors. And you see that built into. There's actually a really kind of philosophically subtle problem of this notion of like oracles, right? So like, who can really tell you what the real state of something is because you can't trust that. That eventually got built into languages. So like Erlang, for example, was designed for telephone switches and has this notion of watchdogs built into the language of I'm watching this process and he's watching me and networks of responsibilities. So,
Erlang, created by whom? Ericsson.
Yeah, Joe Armstrong. Yeah, it was implemented in Prolog. Okay. The question? What? Exactly. Yes. Like Algae, where you can sort of have components coming and going, and that's a huge mess. Yeah, this notion of like isolated components is something that just keeps recurring in software engineering, and it's they never quite get it right. In part because it's just so tempting to break layering boundaries.
So another sort of related question, similar question, is ideally we're not creating our entire system, getting software components from other using libraries, using packages. Are there what sort of testing facilities are provided when you pull in modules or packages elsewhere to facilitate your higher level testing?
I wish. Yeah. So really, yeah. So you can't really count on other people to do their own thing. A lot of times you GitHub, you'll see these badges. Have you seen this? Where you say it's passing tests, and then you can they'll use one of these public, like Travis was the main one that a lot of people use for a long time, where they it was open free for open source projects and so on. And they would link to that, and you can see their test results. I mean, you don't run someone else's tests as a general rule, and within your tests.
Right.
So you just have to trust people, unfortunately.
So why don't
if you
we?
could invent a code quality standard, that would be amazing. But probably.
Why don't we? I want to shut things down because I have to leave in a couple minutes. So let's thank Miner. And so next week is Idea Talk, and I think it's Shani on the blockchain and smart contracts. And so we'll see an announcement for it. It will be. We'll watch the announcement. It'll probably be at this same time, but it will be in